Hi guys, for today's video, we are going to talk about mineral resources and energy resources. Okay, so watch this video. So now let's talk about mineral resources. So minerals in our everyday life, even the simplest household items are made up of different minerals such as our cell phone, keys, coins, pencil, makeup, powder, glasses, and many others. Okay, most of them are made from minerals. So terms to remember, please take note. You can actually read this in your handouts. The mineral occurrence, mineral deposit, or deposit, aggregate, and ore. Now, mineral deposits sa ta, okay? So most rocks of the Earth's crust contain metals and other elements but at very low concentrations. For example, the average concentration of gold in rocks of the Earth's crust is about 0.005 ppm or parts per million. Again, ppm is in parts per million, which is roughly 5 grams of gold every 1,000 tons of rock. Diba? That's, again, amazing. Although valuable, extracting gold at this concentration is not economic, the cost of the mining will be too high for the expected profit. Fortunately, there are naturally occurring processes that can concentrate minerals and elements in rocks of a particular area. Now we have two types of mineral resource. We have the metallic and non-metallic mineral resource. So example of metallic mineral deposit, we have gold, silver, copper, platinum, and iron. Examples for non-metallic resources, we have talc, fluorite, sulfur, sand, gravel. Those are the non-metallic resources. Okay? So, the occurrence of a mineral resource in relation to the rock cycle and plate tectonics. The geologic processes involved in the rock cycle play a major role in the accumulation and concentration of valuable elements or minerals. So, during the plate tectonics, the Earth's crust is broken into a dozen or more plates of different sizes that move relative to one another, or the lithosphere. Okay? So we are talking here about the lithosphere. These plates are moving slowly on top and of a hot and more mobile material called the asthenosphere. So the diagram below shows the different mineral deposits that usually occur in different tectonic environments. Now we have different mineral resources and their origins. I think we have five different mineral resources and their origins. Now let's start. First, we have magmatic ore deposits. So these are valuable substances that are concentrated within an igneous body through magmatic processes such as crystal fractionation, partial melting, and crystal settling. And these are magmatic processes. The magmatic processes can concentrate the ore minerals that contain valuable substances after accumulating elements that were once widely dispersed and in low concentrations within the magma. So therefore, these magmatic ore deposits are because of crystal settling. Okay? So we have here examples of magmatic ore deposits. We have crystal settling and fractional crystallization. First, for the crystal settling, as the magma cools down, heavier minerals tend to crystallize early and settle in the lower portion of the magma chamber. So a reservoir or pool of magma within the upper mantle or lower crust. From the basaltic magma, chromite, we have FeCr2O4, magnetite, Fe3O4, and platinum Pt can be concentrated through crystal settling. Okay? Take note for that. Fractional crystallization. In this process, the residual melt contains high percentage of water and volatile substances that are favorable for the formation of pegmatites. So pegmatites is an example of an igneous rock. So most of these pegmatites are granitic. So they are enriched with lithium, elements nga lithium, gold, boron, and some rare elements and other heavy metals. So the fractional crystallization of granitic magmas can concentrate rare earth elements such as cesium and uranium and heavy metals. So pegmatites are formed from large crystals of quartz feldspars. These are used in production of ceramics, the quartz and the feldspars. The muscovite used for electrical insulation and glitter, which may contain semi-precious gems such as beryl, topaz, and tourmaline. Okay. Next, mineral deposit, we have hydrothermal ore deposit. So the concentration of valuable substances by hot aqueous fluids flowing through fractures and pore spaces in rocks. Hydrothermal solutions are hot, residual watery fluids derived during the later stages of magma crystallization and may contain large amount of dissolved metals because, as we all know, solution, okay? They might have be a solute and solvent. So some of the solutes might have been dissolved in there. So the solute more probably are metals. This can also originate from the groundwater, circulating at depth that is being heated up by a cooling and solidifying igneous body or along depths with known geothermal gradient. So hot water can dissolve valuable substances at low concentrations from rocks. As the metal-enriched hot water moves into cooler areas in the crust, the dissolved substances may start to precipitate. There are numerous hydrothermal mineral deposits as compared to the different types of deposits. Okay? So, examples, we have vein-type deposits. So, this is a fairly well-defined zone of mineralization, usually inclined in discordant and typically narrow. So, this occur in fault or fissure openings or in shear zones within the country rock, sometimes referred to as metalliferous low deposits. Many of the most productive deposits of gold, silver, and copper, lead, zinc, and mercury occur as hydrothermal vein deposits. Again, these vein-type deposits are also referred as metalliferous low deposits. Okay. Next, we have disseminated deposits. These are ore minerals that are distributed as minute masses through large volumes of rocks. So this occurrence is common for porphyry copper deposits. Next, we have massive sulfide deposit at oceanic spreading centers. Massive sulfide, ha? So precipitation of metals as sulfide minerals such as sphalerite or zinc sulfide and chalcopyrite or CuFeS2 occurs when hot fluids have circulated above magma chambers and oceanic ridges that may contain sulfur, copper, and zinc come in contact with cold groundwater or seawater as it migrates towards the sea floor. So again, these are sulfide minerals, the deposits. So we have here mentioned. Next, we have strata-bound ore deposits in lake or oceanic sediments naman. So this deposit is formed when the dissolved minerals in a hydrothermal fluid precipitate in the pore spaces of unconsolidated sediments on the bottom of a lake or ocean. So such minerals may contain economic concentration of lead, zinc, and copper, usually in sulfide form like galena or lead sulfide, sphalerite or zinc sulfide, and chalcopyrite or CuFeS2. Okay. Next, mineral deposit, we have sedimentary ore deposit. So these are some valuable substances are concentrated by chemical precipitation. Take note for chemical precipitation. coming from lakes or seawater. So we have here two examples: evaporite deposits and iron formation. So first, we have evaporite deposits. This type of deposit typically occurs in a closed marine environment where evaporation is greater than water inflow. So as most of the water evaporates, the dissolved substances become more concentrated in the residual water and would eventually precipitate. So examples, we have halite or sodium chloride gypsum, borax, selvite, and sylvite also. So those are examples of evaporite deposits. For the iron formation, we have here made up of repetitive thin layers of iron-rich chert and several iron-bearing minerals such as hematite and magnetite. These appear to be of evaporite and are mostly formed in basins within continental crust during the Proterozoic era. Okay. Next, we have placer ore deposits. Okay, so these deposits formed by the concentration of valuable substances through gravity separation during sedimentary processes. So take note for gravity separation during sedimentary process. So that is the process for the placer ore deposits. So it is usually aided by flowing surface waters either in streams or along coastlines. So this process is probably described by the sedimentation, right? So this concentration would be according to the specific gravity of substances, where the heavy minerals are mechanically concentrated by water currents and the less dense particles remain suspended and are carried further downstream. Usually, it involves heavy minerals that are resistant to transportation and weathering. So, examples for these deposits, we have gold. Other heavy minerals, we have platinum, diamond, and tin. So the source rock for a placer deposit may become an important ore body if located. Now for the last mineral deposit, we have residual ore deposit. Okay, this is a type of deposit that results from the accumulation of valuable materials through chemical weathering process. So take note for the chemical weathering process. During the process, the volume of the original rock is greatly reduced by leaching. Okay, leaching, because it is through chemical. So important factors for the formation of residual deposit include parent rock composition, climate. Okay, these are the factors. And relief. Okay. Common deposits are bauxites and nickeliferous laterites. Bauxite, the principal ore of aluminum. So that is bauxite. It is derived when aluminum-rich source rock undergo intense chemical weathering brought by prolonged rains in the tropics, leaching the common elements that include silicon, sodium, and calcium through leaching. So these are the elements that are part of the process of leaching. Next, we have nickeliferous laterites or nickel laterites are residual ore deposits. These are derived from the laterization of olivine-rich ultramafic rocks such as dunite and peridotite. Like in the formation of bauxite, the leaching of nickel-rich ultramafic rocks dissolves common elements, leaving the insoluble nickel, magnesium, and iron oxide mixed in the soil. So secondary enrichment deposits are derived when a certain mineral deposits becomes enriched due to weathering. Okay, so that is for residual ore deposits. So again, those are different mineral resources. We have magmatic ore deposits, hydrothermal ore deposits, sedimentary ore deposits, placer ore deposits, and residual ore deposits.